These are the problems from section 2.1. We're going to use our echelon method that we've talked about in our notes to work these problems. Number one, you're given two equations and you are supposed to solve them. That means find a point that would work to make both equations true statements. So when we've got them written down here, we have x plus y equals 9 and 6x minus y equals 26. Well, what we should notice right off the bat is that we have a plus y and a minus y. So if we add those two rows, if we talk about that this is row 1 and this is row 2, we'll talk about it that way. If we add those together, well, these y's are eliminated and we end up with 7x equals 35. Divide, and you're not going to divide right there. So now we have a new row 2. So if I rewrite my row 1 and I have this row, and you may in your head be thinking, oh, I don't need to do it all this way. Well, this is the echelon way. You're used to solving systems perhaps from college algebra or high school algebra. This is just doing it a little bit different and systematically. So right here, what we want to do is get x to be by itself, and we would need to divide by 7. Well, we'll call that taking 1/7 of row 2 and leave us a new row 2. So when we do that, we rewrite the first row. We have a new second row that becomes x equals 5. Well, that is a solution, and then we back substitute into our other row. So we now have 5 plus y is 9, so y is 4. So that point, 5, 4, will work to solve both of those equations. It is a solution for both of them. All right, let's try number 2. Here's your original equations, and we don't have it nicely like we did in the first one. We're going to have to do a little bit different. So if this could be a positive 3y and we added them, we would eliminate y. So we will write negative 3r2 is going to give me a new r2. So rewrite row 1, and I don't have those numbered. Let's just do this to start with. So I rewrite row 1, I multiply this one by negative 3, and I get this new row. All right. Now when I add these two, I'm going to have a new row 2. So when I add them, I end up with, if I add 4 and negative 24, it gives me negative 20. Add those, they're gone. And add these, I get negative 20. So now I need this x to be one single x. So I'm going to take negative 1/20 of that row and leave me a new row 2. So that's dividing by negative 20 on all of those, which leaves me x is equal to 1. Again, we back substitute into this equation. So 4 times 1 minus 3y is negative 5. Solve that small linear equation down and you get y equals 3. And we have the point, if I go back up here, 1, 3, and this is how you'll put it in your box. It says type in order to pair, so be sure you do that. Number 3, same way. We don't have anything where we could just do something to one equation and make it work. So if I multiply this whole equation by 3 and this whole equation by negative 4, what will I end up having? I will have a 12x here and a negative 12x here. That makes it okay for me to get rid of the x's. So that's what we have written here. Number these. 3 of this row and negative 4 of that row. So I've got my two new rows. Now I'm going to add them to get a new row 2. That got rid of the x's, so now I have negative 39y equals 39. Because when you added these, you got 39. I take negative 1/39 of row 2, so I'm left with y equals negative 1. Back substitute, and you end up with x is 6. And again, your point is 6, negative 1. An inconsistent system has how many solutions? None. It has no solutions. So there's three possibilities when you do solve a system. You can get a unique solution, which is what we got here. You can have infinite solutions when you end up with the same line, or you can have no solutions where they are parallel and they will never intersect. All right. Number 5. In number 5, we need to notice there are 3 variables, but there's only 2 equations. So z is going to be any real number. We're going to call it the parameter, and we solve it a little bit differently. All right, so z could be any real number. And since it's the parameter, we have to keep it. We don't eliminate it. We could look here, and it looks like, oh, that'd be great. We could add these two, and we would get rid of z, but we need to keep it, so that's not going to happen. Let's first eliminate x. All right, if we multiply row 1 by 4 and add it, that's going to become a new row 1. So I've done that there. Then I multiply row 2 by -3. I did that. So we have two new rows. We're going to add row 1 and 2, and that's going to be a new row 2. So when I do that, I still have this as my 1. And then in this one, my x is gone. I've got -y minus 7z equals -2. You want to solve for y in that one. In other words, bring the 7z over, becomes positive there, divide by -1, and you have y equals -7z plus 2. That will be the solution for y. Then you can back substitute that expression right there in your other equation, and you end up with x equals 5z minus 1. That is what x is. So z could be any real number, and then y would have to be -7 of whatever z was plus 2, and x would have to be 5 times whatever z was minus 1. And you can see that those go in the boxes right there. Infinitely many solutions, and then you put your x, comma, and then your y value. All right, now we get some application problems. Number 6 says, if 30 pounds of rice and 30 pounds of potatoes cost $28.80, and 20 pounds of rice and 12 pounds of potatoes cost $15.52, how much will 10 pounds of rice and 50 pounds of potatoes? Well, obviously, we need to know the price of each of those items individually. So you would start by writing that down. X is the price of rice, Y is the price of potatoes. Then use your information here and write each equation. So 30x plus 30y is 28.80, 20x plus 12y is 15.52. Then you follow your echelon method of solving down. You can look at those steps. You end up with y is 0.46 and x is 0.48. And then we end up with our answers for that. Okay, as I was saying that, I realized that there was an issue and a question, and I've fixed that. So let's kind of look at this a little bit closer. When you solve down here and you get y is 0.46, and then you back substitute, and what I had done, and you have to be careful because we all make mistakes, when I substituted back in, I did not use the correct number when I copied down, and so I got the wrong answer for x. And anyway, that's caught and it is fixed now, so you have the correct work in front of you for the video. So when you do that, and you get x is 50 cents and y is 46 cents, and then we plug them in to what we were asked to find. What's the cost of 10 pounds of rice and 50 pounds of potatoes? So 10 times 50 and 50 times 46 cents, we get $5 plus $23, and our final answer is $28. So they're not asking for these values here. You have to have them to get your final answer, but that is what we will find, is that it's $28. We have another application. A person has $12,000 invested in stock A and stock B. A currently sells for $20 a share and stock B sells for $80 a share. If stock B triples and stock A goes up 50%, his stock will be worth $30,000. How many shares of each stock does he own? All right, so first always list what your variables are going to represent. And so we're going to have X is stock A and Y is stock B. So in this statement here, it says $20 a share for A and B is 80. So 20X plus 80Y is going to equal his 12,000. All right? And then it says if A goes up 50%, his stock will be worth 30,000. So if A goes up 50%, well, half of 20, 50% of 20 is 10. So if you add 10, you'd get 30X. And stock B triples in value. So instead of 80, we have 240Y, and that would be equal to 30,000. So read these sentences carefully. They will help you get your equations. Then you do your echelon method where you're trying to solve for a variable. I chose to go for Y first, and you can look through that. And then back substitute for your equation here. Put your 100 in, and you get X is 200. So that means we would have 200 shares of stock A and 100 shares of stock B. So you can look over that and make sure you know how to solve that. And that should help you with the problems for 2.1.